Hi there, I'm Noah, and this is my video on the second lab, in which charged tapes are analyzed using a line charge model, rather than a point charge model. The fundamentals and experimental process are much the same as the first lab, with really only the fundamentals being expanded upon. Newton's second law remains the same, so the amount of charge on a stationary floating object can be calculated using the other surrounding forces, aka F net equals 0. The principle of electric field remains the same, E equaling kq over magnitude of r squared times r hat, and the electric force equaling charge times E net. However, this lab changes the assumption of the two pieces of tape acting as point charges, and chooses to analyze them more accurately as line charges composed of many point charges. When assuming an object is composed of many point charges, the calculation for E changes slightly, to being the sum of all dE, where dE is equal to k times dq over the magnitude of r squared times r hat. When converting this to GlowScript, you use a nested for loop, where the outer for loop iterates through the system being broken down into point charges, and the inner loop being the surroundings being broken down. This creates the effect of all E fields, and by extension FLX, being calculated on the system's point charges one by one. The same experimental data was carried over from the first lab, and this was not done out of laziness, but rather so that there would be an equal basis from which all calculations would be done. Despite the fact that we can assume that the experiment was done with minimal interference, the reality is that that's simply not the case. Getting two extremely similar experiments would be essentially impossible. Anyways, the tape's mass is roughly 0.203 kilograms, as a length of 0.203 meters. Tapes had a separation of 3.8 centimeters. The gravitational force was roughly 2 newtons, and so the electric force was roughly 2 newtons. And Q was calculated to be 5.64 times 10 to the negative 7th coulombs. The assumptions being made are that the tapes are equal, there are only two surrounding forces, gravitational and electric, and that the tapes have been handled minimally. Moving on to the GlowScript code, it was decided that each strip of tape would be made up of 10 point charges. You can see the calculation for the electric field at a given point, and you can also see the nested for loop that simulates the integral. I highly recommend checking out the rest of my code, the link is at the bottom of the page. The visualization and output are almost as what's expected, with the green arrows fanning out from the center. However, the electric force and gravitational force are not equal. So the question is, why is this happening? Assuming that my code is right, the only issue could be that the amount of charge on each tape is wrong, and that the value is being overestimated. When the charge is reduced down to about 4.45 times 10 to the negative 7th coulombs, the gravitational and electric forces balance out, and then uphold Newton's second law. So, what if the tapes were modeled as point charges? As seen from the first lab and as was just shown, the charge on each tape would be overestimated. And on a less related note, the coding would be much easier just having 2 point charges. As for why the estimates differ, when you're looking at the different point charges, it becomes apparent that there end up being different R values, or different distances between each charge. At any DQ system, it can have up to 10 different R values. And so this causes the E field calculations to begin to differ. And so ultimately, this means that the line charge model will be more accurate than the point charge model, because it's more akin to how the tape actually works, as the charge is distributed over the tape rather than simply at one point on the tape. And so for the model to be truly accurate, there would need to be millions of point charges and 3 dimensions being calculated. But because we can't do that, a line of 10 charges will suffice and be better than a single charge. Anyways, that's all from me, and thank you for watching my video.